The bbox expression in Houdini. It's a simple and powerful expression that will supercharge your procedural workflow. Bbox refers to bounding box. And before we get into the bbox expression, let's take a step back and just talk about what a bounding box is inside Houdini. All right, well, let's get started by adding our favorite test model, Gary the Tiki, the Guardian Tiki. And Gary's going to help us explain what a bounding box is. And a bounding box is simply a rectangular volume that encompasses or encloses a object or a group of objects. And we can visualize that by using this bound SOP here. I'm going to click that. And as you can see, Gary has disappeared and he is entombed inside of this rectangular volume. Let's go ahead and bring Gary back. And let's go ahead and template the bound SOP so we can see the rectangular volume around him, the bounding box. And what we're going to do is we're going to grab this transform just above Gary. And you'll see if I rotate Gary, the bounding box reacts. It continues to create an enclosure so that Gary is always inside the bounding box. And the bbox expression works in the same way. Let's take a look. The bbox expression requires two inputs, the surface node and the type. The surface node is basically the op you want to access. Example here is / Tiki Gary or whatever your op happens to be. And then the second input is the type, and you have a choice of 9 different types, the min, max, size in the X, Y, and Z of the bounding box. In order to understand what these different types are, let's go back to Gary for some answers. Okay, so here we are back again with our pal Gary, and instead of the bound SOP here to show our bounding box, I made a little gizmo. It's a little more detailed and shows some more options visually. So here you can see around our friend Gary, our maxes, our X max, our Z max. In fact, let me make this solid for a minute. Our X max, Z max, and Y max, as well as our mins, our X min, Z min, and Y min, each representing a side of the rectangular volume, as well as the size choices that you have within the bbox. And that's our X size, our Z size, and our Y size. And if I go back to my transform and I decide, let's find Gary again. If I decide to scale Gary, like in the Y, you'll see my Y size, you'll see the Y size changes right along with Gary himself. And the same goes with the X and the Z. So again, the bounding box always encapsulates our model, Gary. So hopefully that explains visually a little bit more of what goes on inside the bounding box. And let's move on. Okay, so now that we know where the mins and the maxes are and the size parameters of the bbox, what can we actually do with that? Well, let's take a look at our rubber toy here, and let's say I wanted to place the rubber toy on top of Gary's head. Give Gary a new hat. Connect Gary back here. If I were to look at my bbox parameters and zoom in, you can see here the Y max looks to be right situated on top of Gary's head. So we're going to use the Y max in order to place our little rubber toy friend here. So if I take a transform SOP and I use the bbox function in the translate Y, you can see I'm using the D_Y max option, which again, we'll put that little guy right at the Y max. And there he is. And here he is on Gary. So again, we're going to go over some other examples here next, but just wanted to show you some of the fun things that we can do with the bbox. So let's take a look at some practical examples of the bbox expression. So many times you'll be working with geometry either from other departments, other software packages, other facilities, and that data may be a little unpredictable. It can be a little janky, especially with regard to pivot points and centroids. So in this example, you can see Gary has his pivot point kind of in his mouth. Not good, not what we want. So what I would want to do in this case, let's say I wanted to put the pivot point down here at the base, kind of in the center bottom of the base. Well, if we go back and take a look at our gizmo again here, we can see all of our parameters again. And in this case, we'd want to use X min representing the bottom of Gary's bounding box. So if I were to take that information back over here and move to this Y min here, you can see I'm using the Y min in the bbox function to translate the pivot point. So now I have the pivot point in a more reasonable spot. We have talked about the max and min values of the bbox function. Now let's talk about the size values, X, Y, and Z size. And as you can see, those represent the length of each plane of the rectangular volume, X, Y, and Z. We can use that, for example, in a transform SOP. And if I wanted to say move my Gary based off of the X size and basically move Gary one Gary unit over, we can do it right there. As you can see, he's moved basically exactly the length of one bounding box. And I can do that in the negative as well. If I just give that a -1, multiply it times -1. As well, this can all be done in the Y and the Z using the appropriate bbox function. In this case, I'm translating in Z off of and using the Z size choice in my bbox. You can see it's exactly one Gary unit over. I can also use the copy SOP in the same way. And as you can see here, I have used the copy SOP using the X size choice in the bbox. And no matter how many copies I use, it'll always be moved over one Gary unit. And because it's procedural, and this is probably the best part, if I go back up here, let's say I scaled Gary in the X, his bbox scales along with, so the transform stays the same. It's completely procedural. You don't have to re-enter numbers in over and over. Now, I use the bbox expression a lot inside of DOPS. Okay, back to our friend Gary. What we're going to do this time is we're going to turn Gary into a cloud. Boom. And I did this because I want to get this cloud volume of Gary into a DOPNet. Let's dive into our DOPNet. And the first thing we need to do is put Gary into this smoke object right here. And as you can see, he's cut off. He's not fully in the smoke object because the smoke object has its own kind of bounding box that you have to adjust. So I have to lift him up a little bit here. I'm down here. And that's a little bit big, so maybe size him down a little bit. Oh, I don't want to cut him off. So you can see it's kind of a pain to get an efficient bounding box going. That's not too bad. But the problem is if I change Gary to another object or if I resize him, I have to go through this all over again. So this is a good case to use the bbox function. And we'll do that here. And now you can see the box is completely encapsulating my smoke volume. And here in the size parameters, I'm using the bbox. I'm saying bbox cloud model, which is the input to this DOP. And I'm using the X size, the Y size, and the Z size parameters. So it's basically copying in the bounding box of the Gary cloud into my smoke object. And that's the bbox expression. It's one of those tricks you can put in your bag to speed up your procedural workflow. If you found this helpful, please like and subscribe. And I will see you in the next one.